Hearing nothing, let's move on to Chip, K0CHP, and learn about the kit that every ham ought to have, or the parts to a kit that every ham ought to
What I'm really talking, this was sort of published as tools, but what I'm really wanting to talk about is test instruments. And that's because I am an unabashed test instrument junkie. As you, this rack of equipment on the right here, that's actually my workbench. And I'll talk about that is not the list that every ham should have, but I will talk about it briefly later because I like it. As I go through this, I'm going to talk about 3 criteria that I've tried to establish for each of these pieces of test equipment. And right now, I can't see comments, so if anybody has anything to say, I'm not sure how I would do that, and I don't want to screw up the presentation. But if anybody has questions or whatever, please pop in when appropriate, okay? So the criteria, the first thing I'm going to talk, include a number for, is ease of use. From 10 being very easy to 0, don't try. The value, which I mean in terms of usefulness or information of value to the average general class amateur radio operator, with 10 being very, very valuable and useful, and 0 being not so much. And finally, priority. These are things that, 1, every ham really should have one of, and 5, not so much that it's not useful, but it's a very specialized piece of equipment that the average ham probably doesn't need to have access to one of very often. Okay, so we're going to start out with multimeters because that's sort of where everybody starts, and almost any meter you can get your hands on will be usable, even the little cheapies. I'll talk about details in a minute, but the features you can add to these that make them more expensive and more specialized and more flexible are capacitance measurement, high current ranges, hold capability, true RMS. I'll talk about what that means, temperature measurement, computer interface, clamp or blade type, so it's non-invasive, transistor testing, audio feedback for open or shorted circuits, and many more. Talking about the things I've got listed here, I was stunned to find that my Simpson analog, how many people have a Simpson analog meter sitting around someplace? Amazon is selling these things for $343. And it's amazing. It's still a great meter. There are stories about the Simpson and the Western Electric version of this thing. You can get analog meters cheap. You can get them expensive. The nice thing about analog meters is you can watch trends easily. The little cheap $5 to $10 Harbor Freight meters, I've got a half dozen of them. They're great. I keep them around. They work fine. They're perfectly serviceable. You need to understand what the limitations are. I have several of these probe meters. You can usually find them for 20 to 50 bucks. They're very convenient when you're making a lot of measurements in small space. The clamp type meters are great for non-invasive measurement of current. That's what the clamp part does. You just snap it around one of the wires and it displays current. But AC has been available and pretty cheap for a long time. There are now coming on the market some DC clamp meters that are, if you think about what that's doing, it's really a pretty clever thing. And but they're much more expensive. And finally, high-end digital meters, 75 to as much as you want to spend on one, typically have more digits displayed, true MS capability, and some other measurement capabilities. So you can find a perfectly usable multimeter for under $10 up to hundreds of dollars. Ease of use, depending, is, I would call it around an 8. Most of the time, you just put 2 leads on and measure a voltage. It's easy. The value to the general class amateur radio operator, I would say this is the highest. It's a 10. And for, again, the general class amateur operator really should have one of these things around. Use it to test batteries, power supplies, cables, plugs, connectors, circuit components, just about any electrical thing you can think of. 2 wire leads. With each of these things I talk about, I'm going to try to talk about how you connect it and what you can measure with it, what you can do with it. With a multimeter, it's 2 leads, typically. The leads connected in parallel for voltage and resistance measurements, for capacitance, and in series for current measurement. Generally, it should be probably your first instrument as an amateur radio operator. The basic ones measure AC and DC volts, AC and DC current, and resistance. Number of digits is one of the things that differentiates the better ones from the worse, and you'll see them listed by some number of digits plus 1/2. The half refers to a 1 in front of the other digits. So a 3.5 digit meter can measure to 1.999. A 4.5 digit meter can measure 19999. 4 digits after the 1. So that's what that half digit refers to, is just the 1 in front of the other digits. Cheap meters are great. Like I said, I've got many of them, basically 1 in every car. Just be aware of what their limitations are and the fact that it is a $10 meter, and it's probably not going to be as accurate as a more expensive one. But for measuring a 12 volt battery or 13.8 volt car DC circuit, perfectly adequate. Analog meters, the old needle meters, are still very useful. They're especially useful for visually detecting trends of a circuit and for tuning. It's much easier to tune to a particular value using a needle than it typically is using a digital meter. Non-true RMS, I talked about a little bit, is for AC voltage, and it's the non-true RMS AC voltage measurement is really only accurate on pretty clean sine waves. On a not real clean sine wave, for example, the output from an inverter, especially what they call it, a approximate sine wave inverter, it's not going to be as accurate as you might like for it to be. True RMS is actually a root mean square calculation of the true power value of the voltage. And it's really the right way to measure any AC signal, but you're going to pay more for it. And in most cases, it's not necessary. It's been interesting to me that when measuring the voltage out of transformers, that's frequently not a really good sine wave. So true RMS is a much better way of evaluating the output of a transformer, for example. Clamp meters are wonderful for non-invasive. You just clamp it around one wire on a power lead, and it'll show you the AC current is easy and cheap. You can, I think Harbor Freight has a clamp AC meter for under $10. DC capability for clamp meters is new and a bit expensive, but it's kind of magic, frankly, when you look at how it's doing that measurement. But they're wonderful. And besides the clamp mechanism, there are increasingly what they call blade current meters, where it has 2 fingers, so you don't even have to push a button to open the clamp. You just slide the 2 fingers around the current carrying wire, and it makes the measurement. They're very clever. Okay, let me see if I can figure out, give me just a second here, to see if I can figure out a way to get my comments enabled. Just in case anybody's trying to talk while we're doing this. Well, I'm going to give up on that and keep going.
Chip, try selecting chat.
Where? I'm just looking at the small screen right now.
No, it's at the very bottom of my active screen, right next to the participants list.
Okay, hold on just a minute. Got too many things on the screen here. Ah, there we go. Okay, I've got it. Very good. So if anybody does, there we go. Have any requests during this, I'll try to pick those up. Okay, so the next kind of instrument I'm going to talk about is SWR and power meters. Incidentally, somewhat embarrassing, and my wife's listening, so I'm not going to go in a lot of detail, but everything I'm going to show you pictures of tonight is something that I actually have. So, yeah. You can spend anywhere from 50 to many hundreds of dollars for a power SWR meter. Again, this is one of the early things that a new amateur radio operator should probably pick up. Ease of use is very high. They're extremely easy to use. If you're trying to figure out if an antenna is working at all, or if your transmitter is actually producing any power, it's a critical piece of equipment. So the value is very high. And again, the priority is very high, in my opinion. SWR power meter measures forward power, reflected power, and standing wave ratio. That's what they're for. They are a two-port device. One port is connected to the antenna. You disconnect your antenna from your radio, connect it to the SWR power meter, and use a patch cable to go between the power meter or the meter and the transmitter. Three basic kinds: cross needle, which I'll describe in a minute, direct reading, either with an analog meter or with a digital meter, and then digital devices. For example, can you see my cursor there on the screen? Somebody nod. Okay. Yes. This little guy's kind of cute because it shows forward power, reflected power, and SWR all at the same time with a bar graph display and some other information. And I think these are on eBay or at Amazon for around 40 or 50 bucks. So where these analog meters are kind of traditional, and I like having them and watching them, but they're $60 or $70. So these little guys are great value. They present a great deal of information, and they're very easy to use. With the cross needle meter, it takes a little bit of experience and practice to read them. It literally has two gauges, two needles on the meter. One of them shows forward power, the other shows reflected power, and where they cross, there's annotation for reading the SWR. It works fine. They're great to use. It gives you a quick visual indication. Having the reflected power needle is kind of neat because you can, as you tune the antenna, you can see that needle come down, which is another case where having an analog meter is actually an advantage for tuning. But the SWR indication is not nearly as precise as it would be with, for example, a digital meter. Not that, in general, with SWR, if you're within 20%, you're plenty good enough to do what you need to do with an antenna. And let's see, where are we? Remember, you have to key the transmitter to make the measurement, but you're going right through the meter out to your antenna. So when you do that, either use low power, or remember you have to ID because you're on the air. So when you make a measurement with an SWR or power meter, remember you do have to ID every 10 minutes for regular FCC requirements. And remember also that this does not tell you the antenna is actually radiating anything. A dummy load has wonderful SWR, but it doesn't transmit anything. All these meters are going to tell you is how happy your transmitter is with the load you're putting on it. Okay. And again, most antennas can be tuned while you're watching the meter, either by lengthening and shortening the antenna, by loosening an Allen screw or whatever, or by adjusting loading coils or caps. And that goes for HF and VHF as well. That's something I didn't mention. This kind of analog meter typically comes in a flavor for HF and a different $60 flavor for VHF and up. This little guy, as I recall, covers pretty much HF to the 2 meter band. I don't think it goes up to the 3/4 meter band. On the other hand, SWR 3/4 meters becomes a little bit of a different problem anyway. This one actually has band switching between HF and VHF, UHF. So remember, when you're looking at meters, take into account what frequency range you want to use it for. Most modern transceivers have built-in SWR and forward power meters. Again, this is only going to tell you how happy the transmitter is with the load you're putting on it. It does not tell you if the antenna is actually transmitting anything, actually radiating anything. Many, but not all, antenna tuners, like this MFJ model, have built-in meters. This one I particularly like because it has a very full function digital meter that I'll talk about in a minute, as well as I took this looking into the light and didn't get the cross needle meter to show up very well, but this is a standard cross needle forward reverse power and SWR meter. So it's kind of got everything all in one box for you, along with the tuner. This is a little bit difficult to put a price on because obviously transceivers can cost anywhere from several hundreds of dollars to many thousands of dollars, and tuners can cost anywhere from hundreds of dollars to, I think MFJ's full legal limit tuner with meters is approaching $1,000. So you can, there's no good way to put a price on this. They tend to be very easy to use because they tell you whether your transmitter is going to be happy. The value is very high. I put it at 10. And I put the priority high because for any amateur radio operator that's buying a modern radio or tuner, you probably should include power and SWR in the feature list of the radio or tuner that you're looking at. Again, measures reflected power, forward power, and SWR. Again, cross needle, direct reading, or digital. Many modern HF transceivers, like the IC7300, can actually produce a fairly crude plot of standing wave ratio across a frequency range. Even though it is admittedly fairly crude, it's very useful for getting a feel for how your antenna is going to work over the entire 40 meter band, for example. Okay. Generally, the tuners with built-in meters can't do that plot function. Again, remember, when you're testing these things, unless the tuner and transceiver have the ability to go to a low power mode when they're transmitting, you need to ID if you're transmitting at full power and using these meters. And personally, I am very fond of the MFJ digital tuners. I don't like dummy lights. Most of the other tuners you can get only have a green or a red LED. The tuner knows what it's measuring. It just won't tell you, and that annoys me greatly. So I really like the MFJ tuners that will tell you everything, what the capacitance is, the impedance, complex impedance, everything it's doing, and lets you twiddle the capacitance and inductance if you choose to. And this particular, the smaller version of this tuner that does not have the cross needle display, I think sells for a little over $200. This version sells for something like $300. And I literally, and I am saying this is a literal fact, I have used this tuner to tune a barbed wire fence as an antenna. Again, key thing to remember with tuners is the tuner can be equal to a dummy load. So even though it's tuned to that chunk of barbed wire, it doesn't mean it's actually transmitting anything. In that case, it was. And I was stunned to find that I actually made a couple of contacts on 40 meters out to about 150 miles using a couple hundred feet of barbed wire fence, for what it's worth. The only piece of equipment in this that I am going to recommend by model and brand is this little guy. I am delighted with this thing. They're around, I think the last time I checked on Amazon, this NESECU frequency counter multimeter sells for around $58. Its ease of use is ridiculously easy. The value, I think, is as high as a multimeter for even the technician amateur radio operator, and I would put the priority very high. It measures, if you put it close to your radio, meaning with a 5-watt HT, 10 yards, it will read the frequency that you're transmitting at, any CTS or DCS encoding you have. It actually has a fairly high resolution along with digital display of RF signal strength. This is a tremendous little device. You literally push the red button long enough to turn it on, put it close to your transmitter, which with my HF rig at 100 watts is 50 yards, and key up and talk, and it tells you what you're doing. The neat thing about this is, unlike an SWR power meter, this actually tells you what's coming out of the antenna. It lets you, the whole point of us doing stuff with radios is to get stuff to come out from the antenna. This tells you if something's coming out from the antenna. It answers the question, which are key ones to me as an amateur radio operator. Is my transmitter doing what it says it's doing? And is it doing what I think it says it's doing? As I said, it's one of my few specific product recommendations. This may be one of the things I buy another one to put into the ham pool, because, or the club pool, because I like this little guy. And look at the frequency range, 2 to 2800 megahertz. This is just, it's a marvelous little device. The signal strength meter is actually high enough resolution. I have used it to map the signal strength around my car for my roof-mounted antennas and get a feel for where the lobes are out of my my 2-meter antennas and 3/4 meter antennas on the truck, which is kind of a neat thing to be able to do. A couple of people have come to the house for us to, they just weren't convinced that their radio was actually particularly transmitting the CTS tones that it said it was. Hold this within a couple of yards of where they're transmitting, and it instantly tells you if they're on exactly the frequency they think they are, and if it's broadcasting the CTS tone it says it is. Okay, antenna analyzers. And I have to say, after having done the VNA presentation sometime back, and I'll hit those in a minute, I've got these 2 antennalizers, and I own a couple more as well. And at this point, I consider them to be obsolete pieces of test equipment, which is a painful thing to admit, but it's where we are, you know. Technology marches on. 50 to hundreds of dollars. Tend to be very easy to use. Value's high because it tells you, without having to connect a transmitter, how well, what your antenna loading is. And the priority is about, I would say, medium for the general class amateur radio operator. Neat thing about it is no transmitters needed. Most of them allow you to characterize an antenna over a fairly broad frequency range. So if you want to know, if you've tuned even a VHF antenna very precisely for the Pikes Peak repeater frequency, and you sweep the 2-meter band, you're going to find that antenna actually isn't working nearly as well at the top end of the band or the bottom end of the band. So these things make it very easy to do a graph of a particular frequency band. And even though I really like VNAs, these things are substantially easier to use. And that's why I have the priority on them that I do. A single port, you just connect the antenna, tell it what to do, and it does it. You can tune the antenna while it's sweeping. It's low enough power, you don't have to worry about IDing while you're doing it. So it's a compact and easy to use tool that makes it easy to tune an antenna. And incidentally, this little guy you can still find on eBay, I think for under $50 or $60. This one is a fairly sophisticated MFJ product. And I think it only goes up to the 2 meter band, as I recall. But there are several $100s, and while worthwhile for the price, they're a little bit pricey when you can get a vector network analyzer for $60. I keep losing my cursor on here when I move, so it takes me a minute to get back to push the next button. So talking about VNAs now, the nano VNAs, I did a presentation on these a while back. And I was so impressed with the little $60 one that I bought the new bigger one with the big display, and it's marvelous. I love the big display. It's more resolution, and it's just very nice. And those are, I think around $120, something like that. $50 to hundreds of dollars. Ease of use is substantially lower than just an antenna analyzer. There is a learning curve on these, and it's not terrible, but you're going to invest a half hour in figuring out what the heck it's doing and how to get it to do what you're asking it to do. The value, I think, of these is enormous. They're such a sophisticated, flexible piece of test equipment that I think they're at the very high of the value list. Because of the ease of use factor, for a general class amateur radio operator, I would put these at a relatively lower priority for that kind of operator. 1 or 2 port for antenna load testing, single port, use it just like an antenna analyzer. Quite a few more buttons and menu steps to push, but basically does all the things any antenna analyzer does, plus a whole bunch more. But you can also use it to very precisely characterize cables, filters, amplifiers, any kind of RF network. Here we're showing Smith chart, return loss, 3 or 4 other things. Hold on just a minute. Let me see what's going on here. Yeah, I don't know. Anyway, they even have an ability to do time domain reflectometry. So if you think a squirrel has chewed through your radio cable, your antenna cable somewhere, you can use this to tell you how many meters from the connection the chewed through point is. It's a very powerful piece of test equipment. It literally does everything any antenna analyzer does, plus much, much more, but with a learning curve. And at this point, even with the learning curve issue, I would recommend buying one of these instead of an antenna analyzer. Other people may have different opinions on that. And again, the learning curve is an issue. And I know that we don't tend to think of a software-defined radio as a piece of test equipment. This is the SDR Play. You can generally get them for $100 to $200 depending on the model. It's an absolutely marvelous receiver. This is the relatively new crowd-funded Lime SDR Mini. Has separate transmit and receive full systems. Where the SDR Play, I would put the ease of use at on the order of 9 or 10. With the software, it's really amazingly easy to use. The Lime SDR is a incredibly fun, clever little device. Unfortunately, getting it to actually do something is an exercise in hours of jiggling software and drivers and firmware and stuff. Ease of use is very, very low. It's a developer's experimentation platform, not a ready-to-use out-of-the-box tool. I do consider SDRs a primary test instrument. I'll show you why. Again, the ease of use can be anywhere from 1 to 9. I put the value very high. I think this is one of the early things that most amateur radios should buy one of, especially since you can get into SDRs with the RTL SDRs for $10 and then get it working with an investment of an hour of time with a Windows computer. You can actually see the output of your system, whether your antenna is actually pushing anything out into the world. Analyze modulation, frequency, signal strength, anything else that is in the air. Make sure that I literally, when I'm doing HF and VHF stuff, have this SDR with this little telescoping antenna sitting in the window next to my desk. And that's far enough from my HF antenna and my VHF antennas that I'm not coupling enough energy into it to damage the front end, but it's enough to let me make measurements. Do not connect your SDR directly to the output of your transmitter. You will blow it up. There are now switchers you can get from, for example, MFJ, that will let you leave your SDR connected to the antenna you're transmitting on, and it will supposedly switch the SDR out and isolate it. I haven't used one of those enough to know if it will let enough signal through so that you can look at your transmitted signal, but that's an option to consider. This is clever, and this is why part of the reason I consider this to be an important piece of test equipment. With a directional bridge and an RF noise generator, take the RF noise generator into a directional bridge out to the antenna, and then from the directional bridge, the reflected signal into your SDR, and it will paint you a picture of your antenna's complex impedance, basically. It's a great way to characterize antennas. And you can get a nice little RF noise generator and a directional bridge for under $50 on eBay or Amazon. Now, this is a little bit of connecting things together and getting it to work, but it's, I ordered a bridge and a noise generator, a couple of cables, had it set up and working in about 15 minutes one evening. And it really does give you a very marvelous picture of what your antenna is doing. And then with a 2-port one like the SDR Play here, I can have the antenna on one port, the reflected signal from my antenna on the other port, so I can switch back and forth between the actual transmitted signal out into the air and the reflected signal from the antenna and compare the two. Turns this little SDR into a marvelous piece of test equipment. I'm not going to particularly recommend an SDR here. I've used the SDR Play a lot. The reason I like it is because the software that is specifically tuned for the SDR Play makes it almost a plug-and-play piece of equipment. It's very easy to use. In the last year, along with the receiver software, which is very sophisticated, very complete, some people have put together a spectrum analysis package piece of software that turns this thing into a really full-featured spectrum analyzer. And by stepping, it can sweep from DC to daylight in a single scan with 60 hertz resolution, which is mind-boggling. It takes a while to do it because it has to step bands, but it just makes the SDR play into a great little spectrum analyzer, which again is, in my big test rack, the only thing I'm missing or was missing was a real spectrum analyzer. And I kept looking at them on eBay, trying to talk myself into buying a 50-year-old Hewlett-Packard 8566 spectrum analyzer that at the time sold for $80,000. Now you can pick up for under $1,000, but who knows if they're calibrated. Usually the CRTs are shot, et cetera, et cetera. This isn't quite an 8566 spectrum analyzer. It's close enough for what I need to do. And it saves me from having a what is it, 2200 watt piece of equipment sitting on my test rack. The Lime SDR, I'm just starting to play with this little guy. I am fascinated by it, but it's not an easy to use device. I would call it very fiddly. To get it to do anything, you're going to spend an hour or two messing with software. And incidentally, Steve, if you see any comments come up that I need to know about, please unmute and yell at me. Okay. I said the RTL chipset or chip was developed for the European digital television market back 15 or 20 years ago. The Chinese are now shipping these things by the billions, and you can build a very capable little software-defined radio around an RTL dongle that you can buy on Amazon for $10. It's going to be a little bit frequency limited. There's some other issues with it, but it's a great way to get into software-defined radio for very, very little money. Okay, I'm going to talk just a little bit about panel meters, because if you build anything as an amateur radio operator, you're probably going to end up wanting to be able to have a permanent measure of something in what you're building. Panel meters I define these as special purpose meters that are made to be assembled permanently into generally a do-it-yourself project and continuously measure some particular parameter in that project. You can spend from $5 to hundreds of dollars for these things on eBay and Amazon. And two Chinese, I'm trying not to use the Chinese vendors as much as I used to, but GearBest and Banggood still have piles of these little cheap electronics devices for very little money, and they're interesting, and they can usually deliver them in a week or so. Mainly going to use these for measuring volts or amps for do-it-yourself projects. There are some, generally for current, you're going to have a current shunt, which you're going to remotely wire and then run test leads up to the panel meter. There are a lot of them now that have a coil for non-invasive installation in AC circuits or for DC current. Again, measuring DC current with a coil around a wire, I'm amazed they can do that. That's a very tricky thing to do, but you can get the things for 20, 30 bucks and they work. I've got one in the RV. I'll show you in a minute. I have many more of these in the drawers of my workbench than probably really makes a lot of sense, but that's okay. This is one I have in the RV. It displays an enormous amount of information, which makes me very happy. Use it for in the RV for the electrical and battery system. This one's particularly neat because it has a remote sender with a DC toroid current sensor that communicates with this display module by Bluetooth. So I can have the sender down in the battery box and this thing up on the system monitor in my kitchen in the RV, which is kind of elegant. You can calibrate it to show battery capacity and how far down it is. It's a very flexible and powerful little meter. It has a built-in clock, so it can do calculations on how much battery charge you've used, how much you have left, all sorts of things. It's a really clever little device. I think this particular one was on the order of $35, which is pretty amazing for what it can tell you. And in my slide-in camper and in my travel trailer, I really like being able to have this real-time indication of what my solar charging system, my batteries, and all the other stuff going on in there is doing. This is a little hard to see, but this is a generator distribution box that I made for my big household generator. It has two breakers up here for the two sides of the 220-volt circuit, a volt and amp meter, again with the toroid AC current sensing for each side of the each 120-volt leg of the 220-volt output from the generator. And I actually split the outlet here, so this is on this side and this outlet's on this side of the 220-volt circuit. And then you can't see it on here, but on this side of the box I have an RV power female connector, so I can plug in an RV there. My generator is large. I have another RV connector on this side, so if I need to plug in somebody else's RV while we're running on generators, I can. And then on this side of the box, I have a household generator connector, so that I can start the generator up, move it somewhere out in the yard when I don't have to listen to it, and see if I'm overrunning the generator's capability very quickly and easily. I'm kind of proud of this. That's a neat little box. And if I tried to find one to purchase, and things that didn't do nearly as much as this were running many hundreds of dollars. I think I built this one for about 30. So if we get back to in-person meetings sometime, and anybody would like to see that, I'll bring it along to a meeting so people can take a look at it. This is a little bench supply with meters that I made for my electronics bench in the garage. Has a DC switch here. I've just got a big computer DC power supply back behind the bench that's wired into this. Voltage and current meter, 2 cigarette lighter plugs, because I end up testing things with cigarette lighter plugs a lot, 2 sets of banana binding post plugs, and a little rack of power pole connectors here. But it's a nice use of a power meter. It's very trivial to wire this into a project like this, and lets you see at a glance how much your radio is drawing when you key up, for example. This is an example of the toroid that I was talking about for AC current measurement. This one is a wired to the meter, and you just run the wire through the toroid here. So you have to break the circuit long enough to get access to the wire, but after that, it's non-invasive. These are a pair of, I talked about that current shunt earlier that you use with a meter like this, and you can put this some distance away from the meter, run the lead from the battery through the current shunt, and then out to whatever load, and then wire it to the meter, and it shows the volts and current. It's not we'll put this presentation, I'll send you this presentation as a PDF, Steve, so you can post it. And then people can blow it up if they want to look at it. I found this little guy on Banggood for, I think, $8. And it's another one of the little toroid meters with a little tiny round digital display of current and voltage. And I just bought it because someday I'm going to have a project I want to stick in, and it was cute as hell. Um, cigarette lighter plugs with 2 USB ports. I didn't have any other good place to put it, but I like to know what the voltage is in my car. And this way I can just stick them in every car, and I don't trust the voltmeters in cars on the dashboard. And this lets me real quickly not only see what the voltage in the car is, but see how much current my USB devices are sucking out of the system. So these things you can usually get on Amazon for $7 to $12, and I don't know how many dozens of them I've got floating around, but they're very handy. Okay, oscilloscopes. I've been at many meetings where people have asked me about oscilloscopes. I love oscilloscopes. In general, I don't consider them a primary piece of test equipment for the average amateur radio operator. However, if you want to get into oscilloscopes, this little guy, the BitScope, is $145. It's a 20 megahertz, 40 megasample per second. Samples per second is one of the key characteristics of a digital oscilloscope you want to know about. Spectrum analysis up to about 20 megahertz, an 8-channel logic analyzer, and an arbitrary waveform generator. When connected to your computer for $145, it's just a wonderful little general purpose oscilloscope, spectrum analyzer, general purpose piece of test equipment. If you want to figure out, if you want to get into scopes cheap and kind of figure out if you have any use for one, it's a great way to do it. This is sort of a more traditional oscilloscope. And again, I'm somewhat embarrassed to say this is all my own stuff. I've actually got it upstairs on the bench. This is a gigasample per second digital scope, which 20 years ago would have been a $50,000 piece of equipment. Now they're 400 to 500. This one's a 2-channel. Has actually pretty sophisticated spectrum analysis capability because it's got mathematical processing in it. Again, I would not say this is a primary piece of test equipment for most amateur radio operators, but it's kind of what a modern digital oscilloscope looks like. This is a 1970s 20 megahertz analog oscilloscope, and I still fire it up occasionally because I just like that green trace and the way it works. You know, it feels like an oscilloscope to me. It's a Hewlett-Packard. In the 70s, this thing sold for around $2,000. The fact that, and its capability doesn't even come close to what this little guy can do for $140. I wish we were in person because I'd love to see a show of hands if anybody recognizes this thing. This is a Hewlett-Packard 1980 oscilloscope. The project was started in the mid-70s with introduction dates scheduled for 1980. It is the classic example of snowballing featureism. It was originally defined as the world's first pocket digital oscilloscope. The actual introduced product weighs around 80 pounds and pulls 800 watts. And it's a 20 megasample per second digital oscilloscope that sold for around $20,000. It was a disaster and introduced 5 years late. Anyway, it's somewhat embarrassing to know that I actually have one. Literally, you can find PC-based digital oscilloscopes on Amazon, and actually oscilloscopes with little displays for as little as $40 or $50. For voice kind of analysis, they're adequate. You can still spend many thousands of dollars for an oscilloscope. Frankly, in general, at this point, unless you're doing something very specialized, I don't think it's justifiable. Ease of use for an oscilloscope, it's less than halfway between not and easy to use. To get basic voltage measurements out of it's fairly straightforward, but it's not going to mean anything to you unless you've spent some time sort of figuring out what it's doing. Again, for the general amateur radio operator, I would say its value or usefulness is frankly not terribly high. Priority, again, for the general amateur radio operator, I would put about as low as you can go. It's just not a critical piece of test equipment for most amateurs. Basically, all an oscilloscope does is display voltage versus time. A little more complicated than that, but that's what they're doing. You can use it to observe modulation, fidelity of sine waves, and again, looking at an inverter sine wave, it's a choppy thing, and there are a lot of devices that you can plug into AC that are really not happy with the output from most inverters. You can use an oscilloscope to make judgments about that. As I said, I love oscilloscopes. I'm not going to tell you how many I own right now, but they're really not needed for most hams. Again, if you want to get into scopes, I highly recommend the little bit scope. Most modern digital oscilloscopes have spectrum analysis capabilities. Generally, it's somewhat limited, but it's there, and I use it quite a bit. It's again, it's kind of mind-boggling to me what you can do with these things. But once you have a good analog to digital converter and some computation power behind it, the sky's the limit on the number of different things you can accomplish with that. Key specs you're going to look for in a digital oscilloscope right now, in case you go out looking for one. First thing you want to look at is how many samples per second it does. And generally the frequency of the waveform that you can analyze with a scope is somewhere between a tenth and a half of the samples per second rate of the scope. For example, in a 40 megasample per second digital oscilloscope, you can sort of analyze 20 megahertz signals. Really, it's somewhat less than that. Second thing you want to look at is the bandwidth, this analog bandwidth, like the 20 megahertz spec here. And finally, how many bits the analog to digital converter provides. Finally, this is my engineering test rack. I'm not going to go through a lot of detail on this, but what I have here is a precision power supply, because I occasionally test stuff that I want to know to within a hundredth of a volt or a hundredth of an amp, what I'm doing with it. This is an arbitrary waveform generator, which is kind of redundant now. It doesn't do a heck of a lot more than my $145 bit scope does, frankly. Oscilloscope and spectrum analyzer, little standard power supply. This is kind of a neat device. It's a multimeter that is 4 lead, because when you're measuring very low resistances, the resistance of the lead becomes part of the measurement problem. And if you don't calibrate the circuit, the test circuit properly, it can be misleading. This actually lets you use 2 leads to put the test current through the resistor under test, and 2 other leads to measure the voltage across it. So you can get very accurate measurements of very low resistances. And it's a 5.5 digit multimeter. So it can do very precise measurements. This is a really, to my mind, this is the 5315 frequency counter. I've got several of these, and it may be the finest, relatively low-cost frequency counter ever produced. It's a computing frequency counter, which means that it can give very, very precise measurements of very low frequency signals, a tenth of a hertz, for example. But it also goes up to 1.3 gigahertz. This thing I love. It's an RF signal generator, HP, of course, and I can use it to characterize radio receivers with sort of ridiculous precision. And finally, at the bottom here, a precision audio, where audio frequency means up to 30 megahertz for engineers, function generator that's very precise in frequency, so I can use it to actually do a lot of HF receiver testing. The original value of this rack of equipment when this stuff was new would be hundreds of thousands of dollars, but on eBay now you could put it together for 2 or 3. It's kind of sad. I use it for transmitter and receiver testing and characterization. And a lot of the projects I work on end up somewhere in this rack getting tested or tuned, which is always a major issue. Okay, sort of my look at test equipment. I'm going to turn this off and go back to general so I can see if anybody's got any questions. Okay, hold on. Let me see what we've got here. I see 30. RTL SDR saved my senior project at the university. Yep. I love the RTL SDRs. It's amazing what you can do with a $10 USB dongle. Cool up, yep. Who makes, Jim, who makes what? I don't know what you're referring to there, Jim. If you can get back in and let me know what it is you're asking for. Yeah, New Elect is actually
that was the RV Bluetooth battery meter.
Oh, to be honest with you, I could probably look on the back of it and tell you. But if you look on eBay or Banggood or something like that, look for remote sensor battery monitor or something like that. And I think you'll find it. If you don't, let me know and I'll look it up for you. Yeah, New Elect is actually absolutely the cheap RTLs you buy on Amazon and eBay are sometimes of questionable quality. And New Elect is a manufacturer, producer that will absolutely give you a tested and true and guaranteed product. Yeah, I use the SDR as a pan adapter all the time. I actually use it more as my general purpose receiver than I do even the receiver on the 7300 because it gives me some additional features. I can have a big display of what's going on over an entire amateur radio band, see something that looks interesting pop over there. On my touch screen, I touch it, it tunes my transmitter to it so I can listen to it and I'm ready to transmit. It's just, the SDR technology is marvelous. I can't praise it enough. Yeah, playing FM radio on the RTL SDRs, it's cheaper than you can buy an FM radio at Walmart for, you know. A lot of people talking about the RTL SDRs, yeah. I don't know about the Diligent Analog Discover 2. Is that, who posted that? Is that another frequency counter thing?
Analog Discovery 2 is kind of a multiple use instrument.
Okay.
One of the drawbacks to all of these really inexpensive but incredibly powerful tools is you are dependent on your computer running through a USB port.
That's
and
true.
If you aren't careful, you'll do what I did here a couple of weeks ago, which is you'll let up a little puff of blue smoke and you'll replace your motherboard, your USB controller, and your analog discovery. So you really have to adapt to some protocols and safety measures because they are not nearly as bulletproof as a nice oscilloscope might be.
Yeah.
But the analog
it
is a two-channel oscilloscope. It's a waveform generator. It's a power supply. You know, it has about 15 things. A spectrum analyzer. Yeah. It does a lot of stuff. And
there's a number of the little. Basically, it's an A to D with a USB dongle on the end, and what you can do with that is pretty mind-boggling. Let me take another quick look. Yep. Yeah, a good option for learning oscilloscopes. I got to go back to the bit scope. Yes, you're going to connect it to the computer. On the other hand, the bit scope is a high quality piece of equipment. It really is. And the USB connection on it is pretty high quality and bulletproof. Some of the cheap little Chinese products you can get, yeah, I'm a little skeptical about the USB stuff they've used. And you can, in fact, blow up the USB connector in your computer with them or more.
And YouTube is your friend here. There's a guy named Alan Wolke.
Yeah.
And Alan has a wonderful YouTube channel, and he is sort of Mr. Tektronix.
Yeah.
And he's the whiz at oscilloscopes on the, you know, YouTube as near as I've found. And I would highly recommend watching his videos on just about anything. He does a wonderful job, and he knows what he's talking about.
Yep. Yeah, just about any of the things here. There's a question about it if I write articles on these, and I have in fact written some articles in the past. It's been a few years. I probably should, because there's some things I do that are somewhat unique. But as Greg said, just about any question you have about any of these pieces of equipment, you can find a dozen YouTube videos on. And a lot of them are amazingly good, particularly on the SDR radios, for example. Greg, the question about the diligent analog Discover 2. I think if you do a Google search on that, you'll find it.
Yeah, the one thing that always irritated me was it's Digilant, and it seemed like they're playing off on Agilent. Really the same thing. What it is a single kind of a chip with some peripheral pieces around it that is a logic gate array. And so it's an incredibly sophisticated technology that brings all of these tools to your desktop.
Yeah. Yep. Question about that frequency counter I talked about, and that'll be posted in the PDF we'll upload of all this. And yes, the answer is that it absolutely works with low power radios like 5 watts. You're gonna have to have it a little bit closer to it, but I have many times, especially with my Banggood and Bofang and Oshan radios, where I'm a little skeptical about how close to the frequency it is, or whether it's actually producing anything, or whether the CTS tone is what it says it is. If you put that frequency counter 5 feet away and key up the radio, it locks onto it perfectly well, tells me exactly what frequency I'm transmitting on. It's interesting. I've actually used that to compare antennas on HTs. It's one of the ways I figured out that the silly orange antenna I have on my headset for the parade actually produces much more transmitted energy than the little rubber ducky on the HT. So that it absolutely does work with low power radios. YouTube oscillator guy or oscilloscope guy, there's a dozen of them. I'd recommend any of them.
Mm-hmm. Chip, I can put a couple links out there.
Okay.
I found one that was a meter that was very similar to the one you were showing for the battery meter.
Yeah.
I found that on Amazon. And then I also put the Digilant Discovery 2 link out there.
Great. Okay. Okay. If anybody else has any questions they'd like to ask at any point, I'm around to answer. And as you can tell, this is a topic I get excited about. I hope this presentation was useful for people. And I'll get a PDF of it sent over to Steve here this evening or in the morning, so he can post it on the website. And if anybody has questions, I'm always around to answer. And I think I am going to get one of those little frequency counters to stick in the pool of club equipment, because it's just handy.
Mm-hmm. Mm-hmm.
Well, Chip, thank you so much for sharing all that with us. I agree. If we had some of that equipment, we'd be rich in equipment. Amazing stuff. No questions. I think we're a little bit after 9, so it's time to sign off. All right, guys. Thank you all for coming. We're going to have our next meeting in August. So more on that to come. And definitely you want to see this guy on Space Weather. He's fun. Take care. Good Good night.